Hey guys, this is Jim, WT1W, and you're watching FEPLabs Radio. Thanks for stopping by. Appreciate it. So today I want to talk about this little guy. This is the EDU06 focus, EDU06 Oscilloscope Test Board, Tutor Board, whatever you want to call it. And this is a fairly simple set of circuits on here with some adjustments to teach you how to use some of the functions of an oscilloscope. The documentation that goes with this is set up in tutorial fashion. It tells you how to hook up the scope, where to hook up the scope, what you're looking at, any adjustments you may need to make to the scope to make those measurements, and then gives you some theory behind it. So you're actually learning while you're doing. For me, I love hands-on stuff. I learn way better when I got my hands in the middle of something instead of reading a dry book. Bless those people's hearts that can read a book and understand it and make something out of it. I need to be messing with something to figure out what I'm doing. So let me change over and we will jump to an overhead view of this and take a closer look and then get into doing some measurements. Okay, so here is a closer shot of the board, and you can see this is called the Velaman EDU06 signal generator board. And one thing I want to point out is this runs on 9-volt AC input, not DC. You can run this on DC, but some of the functions will not work or show up like they talk about in the tutorial documentation because you're using DC power instead of AC power. A lot of the circuits, not a lot, some of the circuits on here are set up specifically for alternating current. Amazon sells this board. They also sell the adapter, a 9-volt AC wall wart that gives you an isolation transformer so you can safely work with your scope without fear of smoking yourself or the scope if you have a wall connected scope. That's kind of a specific thing, and I've talked about that in a very old video I did. So this runs on 9-volt AC. The board has multiple test points on it, and that's these little spots here, SK1, SK6, so on and so forth. And they're all clearly marked on the board where those test points are. And the documentation, as you go through the tutorials, tells you hook up your scope to here and there, or there and there, whatever, for hooking up the ground lead and the probe lead on the oscilloscope. Now, we're going to do a couple of the measurements here, but you do not need to have a high-end scope. However, for doing this and learning how a scope works, a very low-end oscilloscope will absolutely work for all of these experiments and the tutorials that go with this board. The documentation mentions a specific model of small handheld oscilloscope. I have no specific knowledge of that model. I've never used it or heard of it. But I will put links to all of that stuff in the description below as well as descriptions and links to a couple of smaller, cheaper handheld scopes that I have shown on this channel. Any of those will work. This does not require a high bandwidth scope at all. Let's take a look at the documentation and the tutorial and see what we got. Okay, so here is a PDF that says learn how to get the most out of your digital oscilloscope, and it's designed specifically for the EDU06 Oscilloscope Tutor Board. That's the board we're looking at. So this goes through talking about this specific scope, the Velaman HPS 140 handheld pocket scope. I'll find a link to that and put that in the description as well. I'm going to be using a Regal 5074 for a couple of, and it explains what a scope does, the different kinds of oscilloscopes, analog versus digital, what kind of waveforms you can see, what a waveform is, what your probes look like on an oscilloscope, how you connect it, and then basic board setup right here. And then it jumps right into multiple different experiments. So we can measure AC voltage, we can adjust and look at, and I think we'll do this one, we can look at adjustable AC voltage. And the key here is that they tell you in every one of these experiments where to hook up the probes. So on this one, they want the probe tip on number 3, and they want the ground clip on number 2. And then they explain what the experiment is going to show you, any setup that you may need to do for an oscilloscope. And this is the point where if you have this specific scope, these instructions will specifically go along with that. You may want to buy this particular oscilloscope, but any oscilloscope will do. You'll just have to figure out what they're calling a certain function versus exactly what your scope calls a function. And honestly, most of these functions are fairly standard across all oscilloscopes. It should be pretty similar and easy enough to use. So as you can see, as they go through all these, they tell you adjust this, and this is what you're seeing. This is the kind of things that we're looking for here. A little bit of theory. Is there a better way of doing some things? This one measures AC grid frequency. And as we go down, we can see rectified AC single phase, rectified AC dual phase, and what that looks like. And again, some theory to go with it, with some examples. Smooth versus unsmooth DC, which we refer to as ripple. And a lot of you that watch my channel probably already know a lot of this. DC measurements, which is more of a common thing we worry about as amateur radio enthusiasts. We want to know about current and voltage coming out of a power supply or out of a battery as we operate our radios. But there's a lot of things radio related that also happen with AC. So we can have a waveform with an adjustable frequency and so on and so forth. Okay, I've jumped into the oscilloscope menu here. And before we get started doing one of these tutorials, I wanted to set up a few measurements on the screen. One of the cool things about oscilloscopes is it will do math for you. It does a ton of measurements automatically and gives you the results on the screen. An old school scope, you have to count blocks on the screen. With newer scopes, and by new in the last 20 plus years probably, they do a ton of math on screen automatically for you, so I don't have to count blocks on the graticule. The graticule is this set of lines back here on the screen, and each of these blocks can be set to a specific amount of voltage. And then we also have these tiny horizontal these lines going horizontally. That is our time markers. We don't have to count all that because the scope will do that for us. So let's look at voltage peak to peak, and let's look at RMS voltage, and let's look at, I think that'll probably do. All right, now that we've got our board plugged in, we're going to do one of our measurements. And I'm going to hook up the scope. And as you can see now, we have a waveform on the screen. Now this one is going to show us AC voltage and frequency. On the left side of the scope, this is our voltage, this vertical. Let me move the mouse where we can see it. This is our voltage, our amplitude, and then across is our time of the signal. So based on our signal, the scope can calculate. In this case, I've only got it doing voltage measurements, but we could also add in time measurements, which let's do that. Let's see, measure, add, let's do a horizontal measurement. Let's do our frequency and period. There we go. So now here across the bottom, we have some automated measurements. And as I adjust the potentiometer for this, what you'll see is these will change. Our waveform will also change because as I increase and decrease the amplitude of the signal, you see it go down, and this changes our voltages. So our RMS voltage has dropped to 6.1 and our peak to peak is at 17.8. Our frequency, oh snap, is 60 Hertz because we're on US AC voltage, and that's how that works. And then the period is 16.6 milliseconds. And as I crank the amplitude back up, you can see that our peak-to-peak voltage increases, as does our RMS. And there are a whole ton more measurements we could do and get into with this. But this is just a simple example of what you can learn with this board. So using this board and pretty much any oscilloscope you buy on Amazon, no matter if the dollar range is way down at the bottom or way up at the top, you can start to learn what you're doing with an oscilloscope and how to take measurements, what those measurements are showing you, and how you can apply those to other things that you do on a regular basis. You've seen the Smoke and Ape do some videos doing this, and I've done some videos doing this where we hook up a radio antenna connection to the oscilloscope and then key up and look at what the output signal looks like. The Smoke and Ape I know has done one that had a terrible looking sine wave on it, kind of similar to what this one looks like. Let me jump back to this screen real quick. That's not a pure sine wave. And we can tell that because you see how squared off the tops of these are. This is multiple waves. This is a generated sine wave. This is not a pure sine wave. Typically, when you key up a radio, you're going to see a nice smooth curve up and down. But this is a low-end test board. I'm not surprised, but it's close enough for what you're trying to do here. It's obviously an AC signal. In any case, the board itself is not expensive. You don't need to buy a super expensive oscilloscope to use this. One of those sub $100 ones will work just fine for this. I personally would get something a little more useful, buy once, cry once kind of thing. Maybe don't spend a couple $1,000s on an oscilloscope, but maybe don't buy the cheapest one that Amazon sells. In any case, I wanted to share this with you guys. Several of my Patreons and sub-channel members have mentioned that they wanted to do more oscilloscope stuff. So I wanted to get this video out, and then we'll probably do another video here in the next week or two where we go through and do all the measurements and follow the tutorial and kind of look at what all it's talking about. Guys, that's all I've got for this video. Thank you for watching. Please make sure you're subscribed to the channel. Give me a thumbs up. Click the subscribe button down below and click the like and hit the little bell so that you get notified whenever I post any new content. Thanks, y'all. 73.